Welcome to Learn with Money Sunday Maths class. Get your book and pen and let's learn together. You're welcome to class. Let us learn simple indices for GSS classes. What do we mean by indices? Indices are just exponents, what you call power. Yes, when I write numbers like 2 raised to power 3, when I write x raised to power y, when I write p raised to power 1 over q, all these are indices. The singular is index and the plural is indices. There are rules to these indices. Let us start with the rules. The first is the multiplicative rule. In indices, when you are multiplying two numbers whose base are the same but powers are okay, let me quickly explain this to you. When I have a raised to power b, a is the base or the leg or the basis, and b is the exponent or the index or the power. I hope that is clear. So when I have a raised to power b multiplying a raised to power c, you can see that the foundations, the legs, the bases are the same thing. When the bases are the same thing and you are multiplying, this rule of indices says that you should add the power. That is, my result is going to be a raised to power b plus c. Let us take a numerical example. For example, I have 2 raised to power 3 multiplied by 2 raised to power 4. 2 raised to power 3 multiplied by 2 raised to power 4. The bases are the same thing. The legs are the same thing. But the powers are different, even when the powers are the same thing. Once the bases are the same thing, you pick the base and add the power. 3 plus 4. This is equals to 2 raised to power 7. 2 raised to power 3 times 2 raised to power 4 equals to 2 raised to power 7. Let us find out if this is true. 2 raised to power 3 means that I have 2 times 2 times 2. 2 multiplying itself in 3 places. That's 2 raised to power 3. Then this other multiplication between them. And this is 2 raised to power 4 means 2 multiplying itself in 4 places. Times 2 times 2. By the time you remove this bracket, you have 2 multiplying itself in 7 places. Is that correct? 2 times 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 2 and times 2, which is equals to 2 multiplying itself in 7 places. So instead of you to get expressive like this, what about when you have situations like 2 raised to power 47 times 2 raised to power 100? Will you become expressive and write 2 multiplying itself 47 times or 2 multiplying itself 100 times? No, you won't do that. So that is why we have the multiplicative rule of indices. Never forget it. Let's take one more example under multiplicative rule. I have 5 raised to power 50 multiplied by 5 raised to power 16. In this case, would you say that I should express 5 multiplying itself 50 times and 5 multiplying itself 16 times? No, I wouldn't do that. The rule says once the bases are the same, the legs are the same, you pick it once and add the power. 50 plus 16, which is equals to 5 raised to power 66. That is the multiplicative rule. What about division? If this is not multiplication and it is division, let's say the division rule of indices. division rule of indices. The division rule says that when I have a raised power m divided by a raised power n, you can see that the bases are the same thing. A raised power m divided by a raised power n can also be written as a raised power m over a raised power n. You don't cancel out this way. Oh, never do that. Please, never do that. Whether it is expressed this way or this, both are division. And the division rule says that when you have this situation, you subtract the powers. When the bases are the same and you are dividing, you subtract the powers. This is a raised power m minus n. The same thing as we have here, a raised power m minus n. Look at this numerical example where I have 3 raised power 5 divided by 3 raised power 3. 3 raised power 5 divided by 3 raised power 3. The division law says that since the bases are the same thing, I will subtract the powers. This is 5 minus 3. 3 raised power 5 minus 3. That is equals to 3 raised power 2. 5 minus 3 is 2. Let us confirm if this law is true. 3 raised power 5 divided by 3 raised power 3 means 3 raised power 5 over 3 raised power 3. Do you agree? 3 raised power 5 means 3 multiplying itself 5 times. And 3 raised power 3 means 3 multiplying itself 3 times. Now we can divide. 3 divides 3 once, 3 divides 3 once. What you say, 3 cancels 3. And this another 3 cancels 3. What are we left with? We are left with 3 times 3, which is 3 raised power 2. So instead of getting this expressive, that is what the law has simplified for us. When you are dividing 2 indices and the bases are the same thing, you just subtract the powers. Let us take one more example under this. In this example, I'll be combining the multiplicative law and the division law. I will take 7 raised power 2 multiplied by 7 raised power 5, divide everything divided by 7 raised power 7. Look at it. This is multiplication. Do you remember the multiplication law? It says that when we are multiplying indices and the bases are the same thing, we should add the power. So this is 7 raised to power 2 plus 5, and at the bottom I have 7 raised to power 7. At the top, 2 plus 5 is 7. That I have 7 raised to power 7 divided by 7 raised to power 7. Yes, I can cancel out here. Since 7 raised to power 7 is what I have at the top, and 7 raised to power 7 is what I have at the bottom, I can say 7 raised to power 7 can divide 7 raised to power 7, giving me 1. Or better still, I can become expressive this way, that I have 7 raised to power 7 divided by 7 raised to power 7, and use the division law. The division law says when the bases are the same thing, I should subtract the powers. This is 7 minus 7. 7 minus 7 is 0. And that is leading us to the zero index law in mathematics. The zero index law says anything that is raised to power 0 is equals to 1. Just like I have it here. 7 raised to power 7 here 1. 7 raised to power 7 here 1. 1 over 1 is 1. Let us take another law. This has led me to the zero index law, and I will quickly introduce that zero index law. In mathematics, anything raised to power 0 is equals to 1. anything raised by 0 is equals to 1. I will take another example to drive home that lesson.
Take a pause and subscribe to this channel. Click on the notification button to know when I drop new videos.
0 index. Anything raised power 0 in mathematics is equals to 1. Whether it's A raised power 0, it is equals to 1. Or B raised power 0, it is equals to 1. 5 raised power 0 is equals to 1. 7 raised power 0 is equals to 1. Anything raised power 0. Look at the example we saw the other time, where I have 7 raised power 5 multiplying 7 raised power 2 divided by 7 raised power 7. That gave us 7 raised power 7 divided by 7 raised power 7. Since what I have at the numerator is the same thing I have at the denominator, we know that 2 divided by 2 is 1. 5 divided by 5 is 1. The same way, 7 raised power 7 divided by 7 raised power 7 is 1. But by the time we get expressive, using the division rule, we have 7 raised power 7 divided by 7 raised power 7. This is giving us 7 raised power 7 minus 7. 7 minus 7 is 0. That is 7 raised power 0. And using this rule, anything raised power 0 is equals to 1. Just like we got 1 here, the result is 1. I hope we understand the 0 index rule. There is another rule we call the fractional index rule. Fractional index rule, where the power, the index, the exponent you have is a fraction. Fractional index rule. Fractional index rule says that when I have a raised power 1 over n, it means what I have is nth root of a. The nth root of a. Look at this. When I have 5 raised by 1 over 2, this means the square root of 5. When I have 5 raised by 1 over 3, that means the cube root of 5. When I have 5 raised power 7, this means the 7th root of 5. That is what I have. Look at situations like this. Simplify. Simplify 125 raised power 1 over 3. 125 raised power 1 over 3 means cube root of 125. Cube root of 125 is asking for a number which will multiply itself 3 times to give me 125. Can you give me that number? That number is 5. 5 times 5 times 5 is 125. That means the cube root of 125 is 5. Because it is only 5 that will multiply itself 3 times to give 125. So cube root of 125 means the number which when multiplied by itself 3 times will give 125, and that is equals to 5. Let's take another example under this fractional law of indices. Let us take 16 raised power 1 over 2. 16 raised power 1 over 2. 16 raised power 1 over 2 means square root. 2 is a square. square root of 16. Square root of 16 means what is the number which when multiplied by itself 2 times will give me 16. That takes you to your 4 multiplication table. 4 times 4 is 16. 4 is the only number which when multiplied by itself 2 times will give 16. And the square root of 16 is 4. Let us take another question. Like when I have 81 raised power 1 over 4. 81 raised power 1 over 4. This means 4th root of 81. It is asking for a number which when multiplied by itself 4 times will give 81. Can you suggest that number to me which when multiplied by itself 4 times gives 81? I think you get it. That is 3. 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 is the number which when multiplied by itself 4 times gives 81. And that means the 4th root of 81 is 3. That is that about the fractional index rule. Let us look at the negative index rule. The negative index rule. Negative index rule means you have a power that is negative, like this. For instance, I have m raised power minus 1. When you see a negative index, it means 1 over. Consider it like that. It is automatic. It is directly like that. M raised power minus 1 means 1 over m raised power 1. It is not this 1 that is 1 over. No. It is this minus at the index that is 1 over. Then 1 over what? 1 over m raised power this 1 here. Look at this situation. If what I have is a raised power minus 2, this minus is 1 over what? A raised power 2. Can you see that? Let us take numerical example. Like when I have 2 raised power minus 3. This minus at the index means 1 over what? 2 as the basis, and the power of 2 here is 3. 1 over 2 raised power 3. 1 over 2 raised power 3 means 1 over 2 raised power 3 is 2 times 2 times 2. 2 multiplying itself 3 times, which is equals to 8. So 2 raised power minus 3 equals to 1 over 8. And this 1 over 8 can also be written as, this is the base, 8. This 1 over is raised power minus, what is the power of this 8 here? 1. This 1 over 8 is the same thing as saying 1 over 8 raised power 1. So that means 2 raised power 3 raised power minus 3 is 1 over 8, and 2 raised power minus 3 is also equals to 8 raised power minus 1. I hope this is very clear. Let's take more examples. Let's take 5 raised power minus 1. 5 raised power minus 1 means 1 over 5 raised power 1. And 5 raised power 1 is just 5, which is equals to 1 over 5. Another example is this. When I have the multiplication law with a negative index, let me start from the top. When I have the multiplication law with a negative index, How do I simplify that? Like when I have 2 raised power 3 multiplied by 2 raised power minus 1. There is no problem at all. We are still going to be making use of the multiplication law. Look at it. Multiplication law says when the bases are the same, add the powers. That means I have 2 raised power 3 plus, this is minus 1. Minus 1. You can see a directed number here. Yes. This is equals to 2 raised power 3. This is plus times minus 1. Plus times minus is minus 1. And that is equals to 2 raised power 2. 3 minus 1 is 2. 2 raised power 2. 2 raised power 2 is 4. 2 times 2, 4. So this can be simplified this way. But there is also another way of simplifying this using the negative index rule. What I have here can also be simplified this way. 2 raised power 3 times 2 raised power minus 1. 2 raised power 3 times this negative index means 1 over 2. I hope we know that. 1 over 2. So we can simplify that way. 1 over 2 raised power 1. So this means I have 2 raised power 3 at the top, 2 raised power 3 at the top, over 2 raised power 1 at the bottom. 2 here 1, 2 here 1. Then I am left with 2 times 2. 2 times 2, which is equals to 4. So whether you take it this way or following the negative index rule, both are correct. Before I leave you, I want to mention the last rule of indices, which is called the power of power rule. Power of power. This power of power rule means you have a power inside the bracket and another power outside the bracket. Like this. I have a raised power m in a bracket, then everything is now raised power n. A raised power m, everything raised power n. This power of power rule says that when you have a situation like this, you should multiply the power. A raised power m, everything raised power n means a raised power m times n. M times n is mn. That means I have a raised power mn. That is what we call the power of power rule. Look at this example where I have 2 raised power 3 raised power 4. This means we have 2 raised power 3 times 4. This is equal to 2 raised power 3 times 4 is 12. That is 2 raised power 12. When you multiply 2 by itself 12 times, it's going to give you the result you have here. To confirm if this is true, 2 raised power 3 is 8. Is that correct? Inside the bracket you have 8 raised power 4. That means you have 8 multiplying itself 4 times. You can confirm that 8 multiplying itself 4 times is the same thing as 2 multiplying itself 12 times. And that is the power of power rule. That is all we will be taking on these simple indices. Make sure you solve problems on simple indices so that you can tell yourself that you are a master of simple indices. I'll see you around.
Thank you for learning with Money. Let's do this again some other time.